So this is a very basic example, but I think it illustrates pretty well one of the many differences between more beginner code and code that you'd see a more advanced developer writing. So here we have an if statement. We check if x is equal to the string of A, or the string of B, or the string of C, and if it is, we do something inside of it. And you might be saying, this seems fine to me, and in a way it is, but it's also sort of redundant. So we're essentially doing the same check 3 different times, but just with 3 different strings. And this also just won't scale very well because clearly there's some options that we are checking x against, but for each one we add, we have to add more and more to this if statement. It's just going to get harder and harder to read. It's going to take up more and more space, and it just gets a little bit clunky. So what we can do instead is say something like const options is going to be equal to an array. And this is going to have our options for what we're looking for. So let's say A, B, and C. And then in our if statement, we could do something like if options.includes, and we're going to use this includes method to see if it includes x. So essentially we're checking if x is inside of this array here. And if it is, we're going to go into the if statement and then we can do something. And of course, you don't need to do this with every single if statement that you ever write. This code up here is also perfectly fine. But if you have something where you think that there's a good chance that there's going to be more and more of these being added, it's probably better that there's an array of those, and then you just check against the array using a method. And I know some people are going to say this is probably going to be less performant because we're creating this extra array. And that is probably true. However, I think this is one of those cases where the difference in performance is going to be completely negligible. However, the difference in readability and just scalability and maintainability of that code is actually going to be something noticeable. Okay, so here I have a function called foo. It has a Boolean set to true. If the Boolean is true, we return true, and otherwise we return false. And this is a pattern that I've seen called bad Boolean Zen, and it's bad for a few reasons. So first of all, we're checking if the Boolean is equal to true, but this is already a Boolean, so we don't even really need to do this. We could just do if some bool. Now, this is JavaScript instead of TypeScript, so there's an argument to be made to do the triple equals true here instead, just because of the fact that this isn't necessarily type safe. But if you do know it's a Boolean, you can just do if our Boolean. But we can go one step further here. We're saying if the Boolean return true, otherwise return false. So if the Boolean is true, we return true. If the Boolean is false, we return false. So this whole thing is actually just sort of redundant. We can't just say return some bool. So we're going to return our Boolean, and that can replace all of this code. And this is just going to be much cleaner. And again, if you do need to worry about type safety, you could do return some bool equals true, but if we know that this is a Boolean, we can simply say return some bool, and it's just going to be much cleaner that way. And this is one I've talked about before, and I've gotten some comments that the original version is more readable and therefore it's better. However, I would personally disagree with that, and I think it's actually sort of objectively less readable. So let me try to show you why that is as well. So let's put this back, and let's see what exactly is the cognitive load of understanding this versus of understanding this. So to understand this, first we have to say, okay, if some Boolean. So first of all, we need to understand what the if statement actually does, which is fine. And then we have to understand what some bool is. So we have to figure out, is this true or false? And if it is true, we need to sort of mentally branch here to say, okay, we're going to be returning true. And if it is false, we have to mentally branch over here to say, okay, we're returning false. So what do we need to do? We needed to understand sort of how if statements work. We need to understand what some bool actually is, and then we need to understand the branching and the return. However, with this version, we have to understand essentially that we have a return, and we have to understand what some bool is to know what we are returning. Those are both things that we had to understand in this version. However, we just no longer need to understand the construct of the if statement and the branching that that creates. So I would say that there's actually objectively less to understand, as well as it's just a lot less code. When there's a lot of this happening at the same time, this is going to create a lot less nesting, which just makes everything easier to follow. So I would actually argue that this is objectively easier to understand, even if as a complete beginner, it might not quite feel like it. As you get a little bit more advanced, it is going to become much easier to understand in those more complex code bases. And ultimately, as professional developers, we do need to recognize that the audience of our code is other professional developers. So even if you might make an argument that this is a little bit harder for a pure beginner to understand, there are no pure beginners in my professional code base. So maybe if you're teaching a class or something, that would make sense. but in a professional code base, I don't think it makes sense. Now I want to look at the idea of idiomatic code, which essentially just means having your code follow the standards and best practices of the language you're using. So here we have a numbers array, and then we're getting the even numbers. So we create a new array and we loop through the numbers array, getting the ones that are even and pushing them onto this even numbers array. So this does get the even numbers out of nums. However, this is not very idiomatic, and the reason for that is that JavaScript is a language where the sort of idiomatic way to do something like this is to do it in a functional way. So the way we should be doing this is something like const even nums. I'll call this even nums2 so it doesn't get mad at us for having a duplicate name. We're going to say this is equal to nums.filter, and we're going to filter each number by checking that the number mod2 is strictly equal to 0. And this code here does the exact same thing as this code here. So it does the same loop. It creates a new array just like this one does. However, for one, it just does it in one line. And I think this line is a little bit simpler and easier to read. But more importantly, this is idiomatic, meaning this is the way that JavaScript developers expect you to be doing things in JavaScript. And when we follow these idiomatic practices, what this means is our code is going to be consistent within itself, but also within the broader ecosystem of the language we are working in. And this makes our code much easier to read, and it also makes it easier for new developers in our code base to get working fast, because they'll be used to the way that we are writing code if we're writing code the same way everybody else in the industry is writing it. Now, of course, this doesn't mean you can never use a standard for loop in JavaScript or anything like that. These things exist in the language for a reason, but just in general, try to have your sort of default way of doing something be that idiomatic style for that language. I love async await. However, the addition of it to JavaScript has created a ton of slow code from people using it incorrectly. So here we have result1, result2, and result3. They're each equal to a call to await and a different asynchronous function. But the issue here is that we do this one and we have to wait for this thing to finish. So say this is something that's calling some database or some API, this is going to take some time. When that finishes, we do this one. That's what await is doing. But this code does not depend on this one. For example, we don't pass result1 in as a parameter to async function 2. We aren't actually using result1 in result2, and we aren't using result1 or result2 in result3. But we're still sort of doing them one at a time. And before we added async and await to the language, this is something we didn't have too many problems with, because the default behavior when you use then chains is that this isn't really an issue. But if we do want to use async await, there is a solution to this. We just need to make sure we're actually using it. So let's say const, and we will destructure the result here to say result1, result2, and result3. And this is going to be equal to a call to await of a function called promise.all. And what promise.all does is it takes in our asynchronous function calls. And I'm going to comment this out just so that it doesn't get mad at us for reusing the names. And we will use our async func1, and we will call that. And then we will have async func2, call that as well, and async func3, and call that one as well. And now essentially what this does is it's combined all three of these into a single await. So we only have one await, meaning that all three of these things can happen at the same time. So we don't wait for one to finish before we start the other ones. And then the result is going to be these three values. So this is actually going to return to us an array, and we are destructuring that array to get result1, result2, and result3. And this is going to be much, much quicker in the case where these async functions are pretty slow functions. Now I want to look a little bit into the idea of encapsulation. So here we have a count of 0, a function to increment the count, and a function to decrement the count. And this is fine to do. However, this is something that you might see as a bit of a difference in a professional code base versus a more beginner code base. So the issue here is that, for one, this means we only can ever do this one time because we only have one count. But also, we are sort of polluting the global namespace. So this is global, or at least global to this module, and as our code gets bigger and bigger, that can become an issue just because we can have conflicting names and things like that. So one thing we can do here is wrap this in a function. So let's say function create counter, and what I'm going to do with this function is essentially the same thing. So we're going to say let count equals 0, and then we're going to return an object. So we're going to say return, and we will have some object, and this object is going to have an increment function on it. So we can say increment, and this is going to be count plus plus, and then we can also have decrement. So let's do decrement, and this is going to be count minus minus, and then we do not need this code anymore. So this is going to be effectively the same thing, but now what we want to do is say const counter is going to be equal to a call to our create counter function. And now we have a count in this counter, which is 0, but we could actually have multiple of these. So we could do something like counter 2 is another call to create counter. Now these have separate counts because the count is encapsulated inside of this function. So we could do now down here something like counter dot increment, and this is going to increment the count in the first counter, but not the second counter, because again, they are not related to each other. And of course, this is another thing where you do need to use your best judgment, and it just depends on the individual circumstance. But most of the time, if you have some global variable, you should at least think about it and think, is there a better way to do this where I don't need that global variable? And oftentimes it will make more sense to do a pattern sort of like this one. And now as you're trying to write this more professional quality code, you also want to make sure you're writing extremely clean code. And for that, you should watch these 10 clean code principles over here.